A good day, everyone. Fellow inmates, fellow in the house. So my name is Surufalo Minwe. If you wanna get better marks, actually excellent marks in mathematics and physical sciences, please hit the number in my bio. Go to my channel and hit the number in my bio for you to get proper tutoring of mathematics and physical sciences grade 12. So this will be the first episode of Master Euclidean Geometry with Felu. So here is the question that we have to solve to master Euclidean geometry. We go a little bit by a little bit. Remember that practice makes perfect. So this is the question that we have here. So the question that we have here, it says Vn and Vy are tangents to the circle at n and y. So the first objective of this lesson is to know how to tackle the questions of Euclidean geometry. So firstly, what you do when you tackle the questions of Euclidean geometry, note this down. Firstly, what you do to tackle the questions of Euclidean geometry, you analyze the information given. You analyze the information given. So number 2, you analyze the diagram. Number 3, you answer the questions. So the mistake that we do to see, in order for us to say Euclidean geometry is difficult, the first mistake that we do is we do number 3 and try to do number 1 and number 2 while doing number 3. Why? Because we are scared that time is not on our side. So when you get to the question, you go to the questions and not analyze the information that you are given and not analyze the diagram. So I'm going to show you how to master Euclidean geometry step by step. So in all the videos that you see below, we do the same thing. We analyze the information, we analyze the diagram, we answer the questions. Do not rush to answer the questions without analyzing. So analyze first, answer the questions after. So I'm going to do this. So we are going to analyze everything together. So as we analyze everything together, we say Vn and Vy are tangent to the circle at n and y. What do you know about tangent? So we are going to underline information that is important in what we are given. So when we analyze the information, we use the information to actually predict some of the reasons that we might use in our questions. So what do you know about tangent? You know the term called theorem. That's the first thing that you know about tangent. What else do you know about tangent? You know the terms from the same point. So you know the Tanko theorem and you know the terms from the same point about tangent. Then we pass. Then they say A is a point on the circle, AN, AY, and Y are chords so that A is equal to 65 degrees. So what do you know about the chords? You know that actually when we generalize the reason about that we can use on chords is actually angles in the same segment. That's the generalized reason of using the chords. So you can say angles in the same segment. Again, now we are analyzing the diagram, the information. Then another thing they say, you have 65 degrees. So if you see an angle in an information given and you do not see it in the diagram, you put it in the diagram. because sometimes you'll struggle. As I said, some of us, we go straight to the questions, and you look at the diagram, you say, "Hore, actually there's less information given in the diagram. I can't really tackle this question," and you struggle, and spend a lot of time because you did not analyze the information. So analyzing the information is important, so that when you see an angle that is mentioned in the diagram and in the information and not mentioned in the diagram, so that you can be able to put it in yourself in the diagram. So analyzing is very important. Another thing, they say S is a point on AY, so that AN is parallel to SV. So it reminds us of what? So this reminds us of grade 9 geometry. Grade 9 geometry, when we talk about parallel lines, we know that parallel lines can give us the alternating angles. Parallel lines can give us the corresponding angles. Parallel lines can give us the co-interior angles. So those are some of the reasons that we can use to find these angles. So that's it. That's the information. Now we go to diagram analysis. When you do diagram analysis, you're actually going to use the reasons that you are given there. Try to use them in order to find the angles, some of the angles. So we are going to start with what? We are going to start with the Tanko theorem. So when we start with the Tanko theorem, we are trying to find the angles that we can find to using the Tanko theorem. So actually what I've seen here, I've seen that angle A and angle Y are opposite. So when we say they are opposite, means they give us the Tanko theorem. They are opposite, they give us the Tanko theorem. So meaning you can say Y3 is equal to angle A is equal to 65 degrees. Why? Because they give us the Tanko theorem. As we can see that Y3 is actually opposite to A, and A is in the triangle that touches the circumference. All the edges of this triangle AYN, they touch the circumference, and Y3 is actually produced by NY and tangent VY. So NY is actually again the chord that is subtending angle A. So it means that Y3 is equal to 65 degrees. So again, using the Tanko theorem, we can say NY is actually equal to A again. NY is actually equal to angle A because it is opposite to angle A. So N1 is equal to A is equal to 65 degrees. Why? Because it is opposite to angle A. So that's the whole information you can use with Tanko theorem. Because when you try it this way, you say, okay, I have to use another color. When you say this angle will be equal to this whole angle, we don't have values, so it is not important to say that they are equal. So another one, we can say this angle is equal to this angle. So it is still the Tanko theorem, but we do not have values for this angle, so it is not that important. So meaning these ones, we are not going to need them here. So we got the angles with the Tanko theorem that we have here. So now we can try to use the tans from the same point. So we have turns from the same point here. So turns from the same point. We have two tangents in this angle, in this scenario. We have two tangents, which is Vy and Vn. So this tangent, they are actually subtended by, they are coming from the same point, which is V, and they touch the circumference of the same circle at different points, as you can see. So actually what this theorem is saying, it is saying that these tangents, they are actually equal because they come from the same point and they touch the same circle. So they are actually equal. Even if we were to move this point and maybe, I don't know, maybe do it this way, it was actually going to be the same thing of saying these things are equal. This our lines, our tangents are equal because they were coming from the same point and they are touching the circumference of the same point, just that at different points. So yeah, I was just showing you there. So this, we are saying this Vy and Vn, they are equal. Why? Because they are turns from the same point. Then after saying that, you know what? You know the properties of an isosceles triangle. You know the properties of an isosceles triangle. The angles, angles opposite equal sides. You know that reason. Angles opposite equal sides. Let me write it down here. Angles opposite equal sides. So angles opposite equal sides, it actually means the angles below the sides that are equal. The angles that are opposite, that are opposite to the sides that are equal. For example, this angle is opposite to this side. This angle is opposite. This angle is opposite to this side. This angle is opposite to this side. So those angles will be equal because the sides are already equal. Or it can be reversed, that if these angles are equal, the sides will be equal. So it's the properties of what? Of an isosceles triangle. So we have what? We have angles opposite equal sides here. So we can say that y3 is equal to n1. So basically this thing, we have already proven it. We have already proven that y3 and n1 is equal to 65. So this will be a way of someone who didn't see at first. For example, God created us different. We don't have the same brains, so we can't think the same thing. Someone would have said n1 is equal to a because of what? Because of the Tanko theorem. Someone else cannot see it and say ny3 is equal to n1 because of angles opposite equal sides. Then after that, say n1 will actually be 265 because y3 was 65. So we have different approaches when it comes to Euclidean geometry. So that's the only way we could use our turns from the same point. So we can try to use angles in the same segment and see if we can use angles in the same segment. So the chords were mentioned there. We have AN. So when you want to see how the angles in the same segment can work, you are going to say AN, which angles does it subtend at the circumference. So AN will subtend y2 at the circumference, only y2. So AN cannot be used as angles in the same segment because it subtends one angle. So what else? We can use yn. Yn only subtends A. So also we cannot talk about angles in the same segment. What else? We have AY. AY only subtends N. So we cannot talk about angles in the segment, which means we are not going to say angles in the segment cannot work. We only wrote it down because we only wrote it down only because it was in the when it was there when we were doing the information analysis. So we go to this point. We have the alternating angles. Alternating angles, we are going to draw Z. Z where in our lines. So we have S2 and Y3. So you can write it down where S2 is equal to Y3 because of what? Alternating angles. And do not forget that when you talk about the alternating angles, you have to name the parallel lines. So we are not done about Z. We can now try to talk about what. So now we can talk about the corresponding angles. So the corresponding angles, we have to draw an F. So an F that I see is here, actually. So you can see that S1 is basically going to be A, and is basically going to be 65 degrees. Because of what? Because of the corresponding angles. These angles are equal because they are corresponding. They give us the F shape. Then the cointerior, obviously you can say this angle and 65, they give you 180. I don't know if you do right now, but yeah, you can say S3 plus S2, they're actually going to be 180 minus 65. So I don't know if you need that, but just keep it into your mind that it might work. That thing might work. So yeah, that's how we do our diagram analysis. We analyze the angles that we can find. Yeah, and then now we are done with our diagram analysis. We have used all the reasons that we can use to find all different angles. So now we are going to the questions. So the first question, they say write down with the reasons 3 other angles that are equal to 65 degrees. So the angles that I see that are equal to 65 degrees, we have written down. So we have written down angles that are equal to 65 degrees. So the first one, we can say it is N. So let me say S1. We have written it down. It is equal to 65 degrees. The second one that we mentioned that it was equal to 65 degrees was Y3. It is equal to 65 degrees. Another one is S2. No, here I was supposed to say N3. I wanted to say N3. So S2 is equal to N3 because of the alternating angles. Y3 is equal to A and equal to 65 degrees. The other one is N1 is also equal to 65 degrees. So you have 3 angles that are equal to 65 degrees. Then meaning we have answered our questions, and we also give the reasons. So we have talked about the reasons, we have talked about the Tanko theorem and the corresponding angles. So now we can do question number 2. So question number 2, it actually says prove that VYSN is a cyclic quadrilateral. So this is a quadrilateral. It's not a cyclic quadrilateral. As you can see, the edges of this quadrilateral are not touching any circle. So firstly, it's a quadrilateral. It's not a cyclic quad. But you have to prove that it is a cyclic quad. So to prove that a quadrilateral is a cyclic quad, you have to keep this reasons into consideration. You have to keep the first reason as external angle of a cyclic quad. So I'm just going to say CQ, cyclic quad, or you can say opposite angles of a cyclic quad, or lastly you can say angles in the same segment. So these are the reasons that you might use. You see, so when you come across these questions, this question, you write down these three angles so that you can see which one are you supposed to use. So what we are actually proving here, we are proving that there's a circle here. So you are proving that there's a circle here that is invisible. There's a circle that is invisible there. So you are drawing down that circle in order for you to be able to answer the questions correctly. So we are going to try firstly to prove with the external angle of a cyclic quad. So when we prove with the external angle of a cyclic quad, we actually go talking about this angle and this angle. And as you can see, we do not have more information about those two angles. So we cut it out. We don't have much information about it, which means external, we cut it out. Opposite angles. So we will be talking about this angle and this angle. Also, we do not have more information about that. We come to this, we talk about this angle and this angle. We do not have more information about them too. We also have this angle and this angle. So if we had this full angle, maybe we could have tried to find this angle, somehow, then solve our question, but we do not have more information about it, which means the only reason that is left is the angle in the same segment, angles in the same segment. So we can try. Firstly, we can talk about S2 and S3 because they are angles subtended by the same chord. It's not a chord yet, but it will be a chord if we prove that is a circle. So we are doing the converse, reverse of the reasons. So it is not a chord yet, but we can pretend that as if it is a chord already. Then we prove that it's a chord. So S2 and S3, we do not have more information about them. So we can try S2 and Vy because they are subtended by SV. S2 and V1, they do not have any information here. Then we can try again. What else? V2 and Y2. So these two angles actually do not have more information, but they are subtended by the same chord. Then we can try S1 and N1. Then you see that this one can help us because why? We said S1 is equal to 65 and we said N1 is equal to 65. So meaning you are just going to say N1 is equal to S1. Why? Because of not angles in the same segment, because it was proven they are not angles in the same segment until we prove that there's a circle. So we have to prove that there's a circle there. The circle that we drew in blue, we have to prove that that circle exists. That is what we are proving. Then now we can say VYSN is a cyclic quad. Why? Because of converse angles in the same segment. So it's converse angles in the same segment. So we have also proven the second question. So lastly, we're going to do this question together. So we have this angle and this angles, they are equal. Then now we have a circle now. We have proven that there's a circle indeed there. So and now the 6.2.3, it says prove that ASN. So ASN is this triangle. ASN is an isosceles. So we talked about an isosceles. We said an isosceles has to be two equal angles. So it can be 65, 65 or 65, 65. And this angle is different from these two angles. So now we can try to find any of those angles and see if it can give us 65 or not. You see, so what I see here, y3, angle y3 is now going to be equal to S2, because we have proven that we have a second. So y3 is equal to S2. Why? Because angles in the same segment. Now we are not saying converse, because they are equal, angles in the same segment. So angles in the same segment, then N3, not N3. Yeah, N3, we said that previously that S2 is equal to N3 when we were talking about, so let me highlight it so that you can see. S2 is equal to N3 when we were talking about what? When we were talking about the alternating angles. We drew a Z here, then we said N3 is equal to S2. So you see, information analysis is also important for us to be able to answer the questions correctly. So what we have here, we have Sn and Y3. That is what I've seen. So angles in the same segment, then we say, so basically we had to write that they are equal to 65. Then another thing we say, N3 is equal to S2 because of what? They are equal to 65 degrees because of alternating angles. Then you name your parallel lines that SV is equal to AN. Is parallel to AN. I'm sorry. Then what else do we write? We write now we can now say A will be equal to N3 because why? They are both equal to 65 degrees. Then now what left is to say triangle ASN is an isosceles triangle. Because why? Because two angles are equal in a triangle. So you are done with your question. So that's it from me for the first episode. This is Fellow on Maths, Fellow in the building. Thank you.